There are two sides to understanding UI design and UI architecture. The first side is the human element, as it is this user persona that represents our focus, which is to create an interface between man and machine. The second side is the technological aspects, layer upon layer of inventions, to finally produce what we understand today as human-machine interaction. Designing a modern user interface and defining user experience is the culmination of more than 570 years of human endeavor and technological evolution. Let's take a look at some of the history to help us understand the science. Many of the technological terms we use to describe interface elements come from a rich history of technological evolution, starting with the Gutenberg press in 1450. The parameters and terms associated today with the cascading stylesheet language, or CSS, find their origins in the first offset printing press. I will demonstrate how these technologies gradually permeated down to ordinary people, and how these evolving baseline understandings shaped our ability to interact with machines. Common CSS parameters find their origin in movable typesettings of the Gutenberg press. For example, typeface, headings, text justification, X height and text alignment, cap height, mean height and baseline, kerning, which is letter spacing, leading, which is row height, content block, padding, borders, and margins were all developed for the Gutenberg typesetting and are used today when building a modern UI. Without understanding these terms and where they come from, it's hard to fully understand how to manipulate them in a browser application today. The importance of these design laws cannot be understated. They represent the design foundations and component positioning rules for all modern software interfaces. By 1450, the vast majority of the world's population were completely oblivious to technological advances. In 1450, except for England and Germany, the rest of the world is still completely in technological darkness. Not all peoples share the same level of understanding and baseline knowledge at the same point in time. 1780 marks the beginning of the first industrial revolution. It is now more than 200 years since the beginning of one of the most incredible periods in human history. The world changed from a handcraft economy to one dominated by industry, machine, and manufacturing. Starting in Britain in the 18th century and from there spread to other parts of the world. Many technological inventions are created for a specific type of industry and problem. These technologies are then applied to completely different industries once they are globally accepted and fully understood. The birth of the calculator in 1822 eventually revolutionized the way all scientific calculations were made. This invention gave birth to the analytical engine and the first programmable computing machine. By 1870, regular people are slowly becoming directly exposed to human-machine interaction and beginning to understand complex technologies firsthand. Women were the first to become exposed to a high level of human-machine interaction via the first mass production machine, the fabric loom. By 1870, human literacy has now jumped to a quarter of the world's population due to the impact of the printing press and its typesetting technology. In 1870, the world's technological advances were limited to England, Germany, and the United States. The rest of the world would enjoy technological benefits of these technologies at a delayed rate. 1870 marks the start of the Second Industrial Revolution. In 1870, the Second Industrial Revolution was another great leap forward for technology and human-machine interaction. In 1876, Henry Ford's motor car and its production line were about to change the face of humanity. Henry Ford brought the rapid advancement of mass production, electrification, and the 5-day workweek to the world. If I had asked people what they want, they would have said faster horses, Henry Ford. This statement speaks volumes about the difficulty when trying to define a product design. A good UI/UX designer must learn to translate what the customer says into what they actually need. This is not an easy task. In 1911, Frederick Taylor wrote The Principles of Scientific Management, which attempted to improve economic efficiency and labour productivity, implementing a scientific approach, training and teaching the worker, cooperating with the worker, and ensuring appropriate division of labour, using science to understand human-machine interaction, takes root in the world. In 1940, Toyota introduced an active QA feedback mechanism. This process provided assembly line workers with the ability to offer observations and improvements to the production process. Feedback is the secret to good product experience. In 1955, Henry Dreyfuss published Designing for People. His design principles set a new standard, and in 1972, Dreyfuss published The Symbol Sourcebook, a guide to international graphic symbols. These are the symbols used in international airports and modern UI interfaces today. When the point of contact between the product and the people becomes a point of friction, the designer has failed. But if people are made safer, more comfortable, more efficient, or just plain happier, then the designer has succeeded. Henry Dreyfuss. By 1970, half of the world was now literate. The Western world and its offshoots are now fully engaged in the human-machine interaction. In 1970, a broad segment of Western society now enjoys a high level of human-machine interaction. Being introduced to technologies from a very early age shortens the learning curve and simplifies a person's ability to understand new technologies. By 1970, the Third Industrial Revolution began. 1970 brought automation and large-scale computers to big business. Large-scale governments and big business begin to harness the power of computing and train specialists to use these tools. A steep learning curve still exists, and only a select few are exposed to this technology. In 1981, the release of Lotus 123 turned the microcomputer from a toy into a serious business tool for the masses. This enabled the average person to leverage complex financial models without having to study economics or mathematics. These spreadsheet applications were referred to as magic. The learning curve is getting shorter, and more people are now being exposed to computer technologies. In 1983, the first GUI-based personal computer was released, and with it, the first engineer complaint. When I saw the Xerox PARC, I saw a caveman interface. You just point and you grunt. A massive winding down, regressing away from language in order to address the technological nervousness of the user. It's interesting to note the refusal of an experienced engineer to adapt to change and simplicity. By 1984, all three big vendors, Apple, Xerox, and IBM, now provided GUIs with various UI components. Not all user interfaces worked in a uniform manner. This confused users. In 1984, the original Apple Macintosh computer came with software, a keyboard, and a mouse. The introduction of the modern UI, natural language functions, and user experience set the standard for UI layouts and UI components until today. From now on, this window layout would become standard for all user interface designs and UI components. Header and footer window layouts, drop menus, the mouse, double-clicking on an icon, drag and drop, natural language used to describe technical naming conventions, all became industry standards from 1984 and forwards. Despite many attempts to try and change and manipulate the consumer, they became the baseline standard. In 1989, the first internet service provider was born. The US and Australia start a revolution. In 1990, HTML was invented, and with it, the birth of the modern UI. In 1992, the World Wide Web was created. The technologies were developed so quickly that the question of how a person interacts with various technologies was often addressed as an afterthought. Mistakes were made. Until 1993, computing technologies were developed and evolved in parallel. The interrelated technologies, such as screens, cameras, hand controls, and keyboards, were all developed separately. These technologies were often flawed in their design. In 1994, Pizza Hut invents online ordering. In 1994, you could sit down at your computer, open your browser, and order a pizza online. As with many technological advances, the market creates new forms of interaction not conceived by the technology's inventors. Who would have thought that eating a pizza would revolutionize human-machine interfacing and create e-commerce via a browser? In 1995, human-machine interaction evolved into the holistic user experience, which refers to the broader understanding of interfacing with a machine. The term was created by Donald Norman, encompassing the overall experience of software and the computer as a complete package. I invented the term because I thought human interface usability were too narrow. I wanted to cover all aspects of a person's experience with the system, including industrial design, graphics, the interface, the physical interaction, and the manual. Donald Norman. Between 1995 and 1997, the way that humanity learned, purchased, and communicated with one another was about to become unified. In 1995, eBay was founded, and in 1996, Hotmail was launched. The year 2000 brought the dot-com crash, and with it, the way that software was to be designed and developed. The interface designs until the year 2000 reflect the tools that were used by engineers to develop them. The software design methodology, referred to as hardware waterfalling, was not producing the required results. This crash was brought about by false hopes and expectations, immature developed methodologies, and a market that was not ready to absorb the massive technological shift about to transpire. Investment business models were also revised and adapted to the new, uncertain reality of software design and the ever-increasing speed of technological advancement. Product UIs designed in this time period didn't generally follow a user flow or workflow design. This confused the users and made learning hard and complex. In 2003, the media revolution begins. iTunes is released by Apple, and the way we digest music and movies completely changes. In 2004, YouTube revolutionizes web-based video. In 2005, the Agile methodology was developed. The focus was to solve user-customer problems and focus on the entire product experience. The Agile mission was to create repeatable and predictable processes that improve productivity and quality. By 2005, almost all the world is now literate and enjoy a high level of technical understanding. In 2005, almost everyone on the planet knows what an app is. Most people now appreciate a good user experience and good user interface design. The customer can now choose from many different products available on the market. They will now start to choose their apps because of the way they look. Features are not the only consideration anymore. 2005 signaled the start of the fourth industrial revolution. From 2005, everything that we thought we knew about the world and human-machine interaction was about to change. In 2006, Facebook changed the world forever by creating the largest unified interactive platform in history. In 2007, the smartphone revolution begins. The mini app is born, and with it, a clear workflow and repeatable processes will soon become the norm. Humanity will now start to relate to UI/UX of an application in a completely different manner. In 2010, traditional media, such as news sites, news companies, and newspapers, are all already dead, and they don't even know it. Social networks and the smartphone bring a lowering of the age of engagement with advanced technologies. The standardization of the UI is now becoming a consumer expectation. In 2012, the smartphone revolution expands to poorer countries and demographics worldwide. By now, many apps have a clear and focused user flow. Today, almost all desktop applications follow this same methodology. By 2012, modern user experience design evolves, and understandings are reached. First, understand the problem you wish to solve. Then define the product's core functionality. Provide early exposure of the workflow to the customer. Gradually expand functionality according to user feedback and requirements. Create clear and simple workflows. And leverage pre-built components. By 2015, responsive and adaptive UI design becomes standard practice for developing a user interface. Adaptive design ensures the best user experience regardless of the device the user is using. In 2016, the use of standard design patterns becomes widespread. These are reusable UI components and layouts used to solve common problems. In 2017, brain implants are sold, machine learning AI becomes widespread, Face recognition systems are implemented, and full virtual reality experience is now available. Now, in 2020, we are entering the era of human-machine integration. There has been an upward shift in the technological baseline understandings by most of the world. In 2020, almost all of humanity is now literate, with a high level of technical understanding. All of humanity is now directly connected to human-machine interfacing via their own personal mobile device. Lessons learned and understandings reached. Human-machine interfacing is always evolving. The interaction is scientific in nature. Baseline understanding is constantly rising. The learning time is getting shorter. The age of engagement is constantly getting younger. User interface design becomes standardized and simplified. User expectations from the UI are constantly rising.